We know related rates are sometimes pretty tricky, but once you practice them, they're not too bad. They'll show up on the AP exam. Our first one we have the radius of a circle is increasing at a rate of 2 inches per second. Bryce,
so we got a circle here, and this is our radius. So that's increasing at 2 inches per second.
So Bryce will write dr over dt equals 2, because that's the rate, it's increasing. So you just gotta label what you know first off.
Right.
And then it's asking, what is the rate of increase in the area of the circle in square inches per second at the instant when the area is 25 pi square inches? So, very good. When our area is 25 pi, we'll have to need that. So the volume of the circle is pi r squared. We have this. So now it's asking, what is the rate of increase in the area? So when it says rate of increase, you're thinking, oh, I gotta differentiate this. So now you differentiate it. So then you get,
We don't know what this equals yet.
so you can write dv dt or dA dt for the area.
And we will know what this equals eventually.
So we're gonna differentiate this. So this would be 2 pi r dr dt, because we're differentiating with respect to time, and since this is our variable, you write dr dt. So now the question is asking,
This is the derivative, by the way.
this is the
This is
derivative.
of the volume.
Now we're talking all about in rates, not in, yeah. So now we want to know at the instant when the area is 25 pi square inches. So now we can put 25 pi equaling pi r squared, because we want to find the radius. So now you can divide things out, divide by a pi. So then you got 25 equals r squared, and then r equals 5. So now that you know that, you put 5 back into your derivative equation,
Okay, we'll rewrite that.
because we're trying to find what is the rate, which this is the rate of increase in the area of the circle. So now we're finding what everything's out. So now we have 2 pi 5 dr dt, and as you know, we already know what dr dt is. So you put 2 back in for dr dt, equaling our dA over dt, or you can also write it as dV over dt. So now once you simplify it, actually you don't even need to simplify it.
That's your answer.
There's your answer, 2 pi times 5 times 2. Back at it with another related rates problem. So we got top of a 13-foot ladder sliding down a vertical wall.
So here's our ladder and our wall. So we got some ground.
What is the leaning tower of Pisa?
So we got 13-foot ladder is sliding down the vertical wall at a constant rate of 4 feet per minute. So our dy dt, because we're talking about the constant rate of when the top of the ladder is sliding down the wall, dy dt equals 4, can actually be negative 4 too.
Actually, yeah.
When the top of the ladder is 5 feet, so we want to know when it's 5 feet, so just
So y
Four.
equals 5.
we'll do when y equals 5. What is the rate of change of the distance between the bottom of the ladder and the wall? So we want to know what dx dt is when y equals 5. So, as you might know, this could be a Pythagorean theorem problem. So we can write up x squared plus y squared equals 13 squared. So now we differentiate because it's a related rates problem. We want to talk about in terms of rates. So we got 2x dx dt plus 2y dy dt equals 0. Perfect. So now we want to know when,
We'll find dx dt.
yes. So we put in, we want to find So we want to enter in our variables what we know. So looks like we know this and this, and we don't know this, but we need to find this x here. So to find the x, you put it in the original equation, you put 5 in for y.
X squared plus 5 squared equals 13 squared. This is 169. This is 25 minus equals, what does that equal? 144. X squared. This is gone. And then you go square root. X equals 12.
So there we go, we got x equals 12. Put this in, back to here, so it looks like we have all of our things. So now we can just fill in what we know.
Plus 2.
We don't know dx dt.
We know dy dt is -4.
We know dy dt equals
0.
0. Now all you do is just solve for dx dt.
So we can minus this whole chunk
So
over
yeah,
here.
quick
Which is 10
simplification.
-40 equals 24 dx dt. So we can divide that 24 dx. But we have it at -4.
You got pluses to the other side.
Oh, okay.
Little algebra never hurt anything.
So this is not
Well, no, that is negative.
negative.
So, dx dt equals 40 over 24, which simplifies down to 5/3. And that is the rate of change of the distance between the bottom of the ladder and the wall, given all this stuff. So there we go.
What's your measurement? Feet per minute?
Yeah,
Yeah, feet per minute.
feet per
Alright.
minute. Very good.
5/3 feet per minute?